Welcome back. So previously, we had used the definition of the derivative, the limit definition of the derivative, to find the derivative of sine x. Right? And using the limit definition of the derivative, we found that the derivative of sine x is equal to cosine x. Right? So when we differentiate sine x, we get cosine x. We also use the definition, the limit definition of the derivative to find the derivative of cosine x. And we found that when we take the derivative of cosine x, using the limit definition, that would be equal to negative sine x. Right? So the derivative of cosine x is negative sine x. We're going to use those two rules plus the quotient rule to find the derivatives of the other four trig functions. Right? So as a reminder, the other four trig functions can be rewritten in terms of sine x and cosine x. And we already know the derivative of sine x and cosine x. So for instance, we can find the derivative of tangent x by using the quotient rule, because we can rewrite tangent x. So tangent x is equal to sine x divided by cosine x. So now we have a quotient, and it's a quotient of functions where we know the derivative of, right, that we know the derivative of. So now we can use the quotient rule to find the derivative of tangent x. As a reminder of the quotient rule, right, so if we take the derivative of a quotient, and so u, we'll call it u divided by v, right, that's going to be equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. Right? So in our example here, the numerator is sine x. The derivative of sine x is equal to cosine x. The denominator is cosine x. The derivative of cosine x is negative sine x. All right, so now we're going to take the derivative of sine x divided by cosine x in order to find the derivative of tangent x. Right? So the derivative of tangent x is equal to the derivative of sine x divided by cosine x. Right? And using the quotient rule, right, it's going to be the denominator, which is cosine x, times the derivative of the numerator, right, which is cosine x, minus the numerator, which is sine x, times the derivative of the denominator, which is negative sine x. Oops, we lost an x. Let me fix that. Can't take the sign of nothing. Divided by the denominator squared. So that would be cosine x all squared. Cosine x times cosine x, that's cosine squared x. And we have negative sine x times negative sine x, that's a positive sine squared x. Divided by cosine x squared is the same as cosine squared x. Now, we could rewrite cosine squared x plus sine squared x. You're more likely to have seen it written as sine squared x plus cosine squared x with the two terms switched. But addition is commutative, and it doesn't matter the order we add two terms in. So cosine squared x plus sine squared x is the same as sine squared x plus cosine squared x. And we know that equals 1, because this is a Pythagorean identity. So I could replace the cosine squared x plus the sine squared x with a 1. So now I have 1 divided by cosine squared x. Right? So now I've got a quotient. Maybe I don't want it to be a fraction like this. Maybe I want it to be a single term. All right, so if we think about that, what is 1 divided by cosine x? All right, well, this is a reciprocal identity. What is the reciprocal of cosine? All right, well, it is secant x. So I could replace the 1 over cosine squared x. I could replace that, put it over here, I'm running out of space, with a secant squared x. And now you've learned the derivative for tangent using the quotient rule, right? And a quotient identity. We replace tangent x with sine x and over cosine x. So the derivative of tangent x is secant squared x. Right? So now you've learned one of the other 4 trig derivatives. Let's learn another one. We've learned tangent. Makes sense to learn cotangent next. All right, so we can find the derivative of cotangent x by using the quotient rule as well. And so we're going to differentiate, oops, not tangent x, we just did tangent x, cotangent x by rewriting it. So cotangent x is equal to cosine x over sine x. I've got tangent in my brain, I guess. Cosine x over sine x. So one of the nice things, by the way, about deriving the 4 other trig derivatives is, well, number 1, you can really see where the derivatives came from. You know, it has some context now. But also, if you ever forget the derivative for tangent x, you could just rewrite it as sine x over cosine x, and then just use the quotient rule to find the derivative. So, and we're going to do the same thing to find the derivative of cotangent x. This is also a quotient. And as a reminder, you can use the quotient rule if we have a quotient to find the derivative. And the quotient rule, if we're taking the derivative of a quotient, it's going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. I'm really trying to make sure my u's and b's look different. Divided by the denominator squared. All right, so the derivative of cotangent x would be the same as the derivative of cosine x divided by sine x. All right, so now we can use the quotient rule. Right? So let's write our derivatives here. So the numerator is cosine x. The derivative of cosine x is negative sine x. The denominator is sine x. The derivative of sine x is cosine x. Right? So we have then we're taking the derivative, that's going to be equal to the denominator, which is sine x, times the derivative of the numerator, which is negative sine x, minus the numerator, which is cosine x, times the derivative of the denominator, which is cosine x. All right, so now, and all over the denominator squared. So that's going to be sine x all squared. So sine x times negative sine x, that's going to be negative sine squared x. And negative cosine x times cosine x, that's going to be negative cosine squared x. And of course, sine x all squared is the same as sine squared x. Right, so now this doesn't look like a Pythagorean identity like we did on the other problem at first, because it's negative. But what if we factored out that negative? Right, so we're going to factor out the negative, and we're left now with sine squared x plus cosine squared x divided by sine squared x. Well, remember that one of the Pythagorean identities is that sine squared x plus cosine squared x equals 1. So we could replace the sine squared x plus cosine squared x with a 1, and negative 1 times 1, now that's going to be negative 1. So we're going to have a negative 1 in the numerator, and we have sine squared x in the denominator. But maybe we want to rewrite that so we don't have a fraction. Right, so what is 1 over sine x equal to? Right, well, this is a reciprocal identity. Right, so 1 over sine x is equal to cosecant x. So now if we have negative 1 over sine squared x, right, that's going to be equal to negative cosecant squared x. And we have now found our second derivative. The derivative of cotangent x is equal to negative cosecant squared x. Kind of makes sense since the derivative of tangent x was secant squared x. Right, so we've derived our second trig derivative of the 4. We can find the derivative of cosecant x by rewriting it as a reciprocal of sine x and using the quotient rule. So remember that, so we want to find the derivative of cosecant x. Remember that cosecant x is equal to 1 over sine x. And this is a reciprocal identity. By the way, the tangent x equaling sine x over cosine x and cotangent x equaling cosine x over sine x is a quotient identity. This is a reciprocal identity. So we're going to rewrite this cosecant x as, we're going to take the derivative of 1 over sine x, because we know the derivative of sine x and we know the quotient rule. As a reminder, that does count as a quotient. If we take the derivative of a quotient, it's going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So in this case, our numerator is 1. The derivative of 1, of course, is 0. The denominator is sine x, and the derivative of sine x is cosine x. Right? So we know we can find the derivative of 1, of a constant. We can find the derivative of sine x. We know those already. Right? And so we can find the derivative of cosecant x indirectly by finding the derivative of 1 over sine x. Right? So now the derivative of 1 over sine x is going to be the denominator, which is sine x, times the derivative of the numerator, which is 0, minus the numerator, which is 1, times the derivative of the denominator, which is cosine x. All divided by the denominator squared. Actually, let me write it as sine x all squared, and then we'll change it. Well, anything times 0 is 0. So we have negative cosine x divided by, so sine x all squared is sine squared x. And again, we might not like having this, having a fraction here as our derivative, right? Could we rewrite that so that's no longer a fraction? Well, what if we take that sine squared x and split that up? Instead of writing it as sine x all squared, what if we wrote it as sine x times sine x? Right? Because sine x squared is the same as sine x times sine x. So that would give us negative cosine x times sine x times 1 over sine x. So you see what I've done now is I've just split up that sine x into two fractions, right? So sine x times sine x is the same as 1. So if I have sine x times sine x in the denominator, that's the same as cosine x over sine x times 1 over sine x, right? I haven't changed anything, right? These are identical. I've just rewritten it. But now that I've rewritten it, I can rewrite this because using the quotient identity, cosine x over sine x, remember, is just cotangent x. So I could replace this with negative cotangent x using a reciprocal identity. We went over this in the last slide, I think. 1 over sine x is just the same as cosecant x. And now we have the derivative of cosecant x. It's negative cotangent x times cosecant x. No longer is it a fraction. Sometimes, by the way, because multiplication is commutative, in other words, it doesn't matter the order you multiply in. So sometimes this is written as, so we've now found the derivative of cosecant x. Sometimes that ordering is switched, and that's equal to negative cosecant x times cotangent x. It doesn't matter whether you write negative cotangent x times cosecant x or negative cosecant x times cotangent x. Either way, you're multiplying three things together, a negative 1, cosecant x, and cotangent x. And now we have found our third trig derivative. Actually, our fifth trig derivative, because we already knew sine x and cosine x. We got one more. And of course, who's left is secant x. So we want to find the derivative now of secant x. Let's say we don't remember it. Right? Well, I do know that secant x, so using a reciprocal identity, oh, there's something odd on my board. It's making it difficult to write on this little section here. A reciprocal identity, secant x is the same as 1 over cosine x. So we could replace secant x with 1 over cosine x. And now we have a quotient, so now we can use the quotient rule. Right? So as a reminder, if we're taking the derivative of a quotient, it's going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Right? And so in this case, the numerator is 1, the derivative of 1 is 0, the denominator is cosine x, the derivative of cosine x is negative sine x. Right, so that's going to give us our derivative. We're going to rewrite that using, we're going to take the derivative using the quotient rule. Right, so we have the denominator, which is cosine x, times the derivative of the numerator, which is 0, minus the numerator, which is 1, times the derivative of the denominator, which is negative sine x, all divided by the denominator squared. Right? Of course, anything times 0 is 0. Negative 1 times negative 1 is positive. Excuse me. So that's just going to give us sine x in the numerator and cosine squared x in the denominator. And again, maybe we don't want it to be a quotient. We could rewrite cosine squared x again as cosine x times cosine x. Actually, the last time you rewrote sine x. That would give us sine x times cosine x times 1 over cosine x. Notice we just rewrote it. We haven't changed anything. 1 times sine x is still sine x. Cosine x times cosine x is cosine squared x. But now we could rewrite these. We could use a quotient identity to change sine x over cosine x into tangent x. And we can use a reciprocal identity. Oh, I have it up. Do I have it up? No, I don't. Oh, yes, I do, right there. If I look carefully enough, I think on the last page I wrote the same reciprocal identity twice instead of looking up. So we already have secant x equals 1 over cosine x. So if secant x equals 1 over cosine x, 1 over cosine x equals secant x. So we can replace the sine x over cosine x with a tangent x, and a 1 over cosecant x with a secant x. Right? Now, the order you write those in doesn't matter. Tangent x times secant x is the same as secant x times tangent x. So sometimes the derivative of secant x is written as secant x tangent x. As long as you have the right terms in that product, it doesn't matter who's first and who's second. And now we have derived all 6 trig derivatives, right? So notice secant x there is secant x tangent x, and where is cosecant? There is cosecant x, negative cosecant x, cotangent x. Probably because the derivative of cosecant x, they wanted to put cosecant first. It's the derivative of secant x, they wanted to put secant first. But anyway, that's the end of my my derivation of these trig derivatives. In the next podcast, we're going to use what we've learned to find the derivatives of all kinds of functions that involve trig functions. Thanks for watching. Bye for now.